On this lecture, we are going to try to solve multiplication of matrices. And before we can do that, we have to follow some rules in order for us to determine whether the given matrices are possible to solve or not. So this is the rule that you must always remember before you multiply matrices. Columns of the first matrix must be equal to the number of rows in the second matrix. This is the rule that you must always remember. The columns of the first matrix should always be equal to the number of rows in the second matrix. So let's say we have this matrix. So this is our first matrix and this is our second matrix. Okay, so let's see if these matrices are legal to multiply. So again, let's review our rule. We must have the number of columns must be equal to the number of rows. So the number of columns for our matrix is, how many columns do we have for our first matrix? So we have 2 columns here. And then how many rows do we have for our second matrix? 1, 2. So we have 2 rows for our second matrix. So meaning 2 columns and 2 rows, they are equal. So it is legal to multiply these matrices. Let's have another example. Let's say the given is so let's say these are the given matrices. So before you operate and do multiplication of matrices, we must see first for these matrices follows the given rules for multiplying matrices. Okay, so let's count the columns. 1, 2, 3. So we have 3 columns. So this is 3 columns. How many rows do we have here? 1, 2. So we have 2 rows. So it is stated in our rules that columns of the first matrix, which in this case we have 3 columns, must be equal to the number of rows in the second matrix. And on the second matrix we have 2 rows. So they are not equal. So meaning we cannot legally multiply these matrices. Okay, so this time we will multiply matrices. Let's perform now the operation how to do multiplication of matrices. So let's say this is the given. Okay, so if this is the given matrices, the question is how we are going to multiply these matrices. So there is a pattern that you must follow. The pattern is you go from left to right and then from top to bottom. This is the pattern of multiplying matrices. You start with left to right and then the second you go from top to bottom. So what do you mean by this? Okay, let me place this pattern at the right side of our board. So the first step is to go from left to right, and then the second step is to go from top to bottom. Okay, so what do you mean by this? Okay, so let's see. Let's try doing the multiplication following this pattern. Okay, so it means that we will multiply first the first row against to the first column. After doing that, we will go back to the first row again and then multiplying that to the second column. First row, third column, first row, last column. Since we have already reached the last column, what we will do next is to go to the second row. Second row, first column, second row, second column, second row, third column, second row, last column. Since we have already reached the last column, that is now the end of multiplying this matrix. Okay, so let's do that in action. So to do that, let's start with 4 times 1. So let's write here 4 Okay, so we have to multiply 4 and 1. So we will do that by writing this down. And then plus 2 and 0. 2 and 0. And then let's continue. 4 and 2. So let's write here 4 and 2 plus 2 and 1. 2 times 1. Okay, let's continue. 4 and 3. 4 and 3 plus 2 and negative 1. 2 and then negative 1. Let me erase this for a while. And then 4 and 4. 4 and 4 plus 4 and 6. So let's write here 4. Okay, so maybe we have to compress this. Let me write this first. Let's write it down here. 4, 1 plus 2 and 0, and then 4 and 2 plus 2 and 1, then 4 and 3 plus 2 negative 1, and then 4 and 4, 4 and 4, and then 2 and 6 plus 2 and 6. So there you go. So let's erase this. So we have already completed multiplying the first row against the columns of the second matrix. So the next move will be, we go to the second row and then we will multiply this second row against the columns of the second matrix. Okay, so let's start doing that. 1 and 1, let's write down here 1 and 1 plus 3 and 0. We are finished multiplying the second row to the first column, so the next move is to multiply the second row to the second column. Okay, 1 times 2 plus 3 times 1. Okay, let's move here. 1 times 3 plus 3 times negative 1. And then let's now move here. 1 times 4 plus 3 times 6. So there you go. Now, after doing this, let's now simplify each element of this matrix. Okay, so let's do that. So let me write here a brace, and then 4 times 1, that is 4, plus 2 times 0, that is 0. So what will remain here is just 4. Okay, and then 1 times 1, that is 1, plus 3 times 0, that is 0. So what will remain here is just 1. And then for this, 4 times 2, 8. And then 2 times 1, that is 2. So 8 plus 2, we have 10. And then 1 times 2, that is 2. Plus 3 times 1, that is 3. So 2 plus 3, that is 5. 4 times 3, that is 12. 2 times negative 1, that is negative 2. So 12 plus negative 2, so it will be 10. Okay, this becomes 10. I will just put the answer for 4 times 3 right here at the top. So 4 times 3, we have 12 plus 2 times negative 1, that is negative 2. And they are unlike sign, so this becomes subtraction. So 12 minus 2. 12 minus 2 is 10. That is why we got this answer. Okay, so let's continue. 1 times 3, that is 3. And then 3 times negative 1. Okay, so we have again to write the answer for this part just at the top. 1 times 3. 1 times 3, that is 3. Plus 3 times negative 1, that is negative 3. Okay, so we have an unlike sign, so we have to subtract. So this becomes 0. So 3 minus 3 is 0. So we have to write here 0. And then 4 times 4, we have 16. Okay, so let's write the answer here at the top. 4 times 4 is 16. Plus 2 times 6 is 12. Okay, so we have 28. So 28. And then at the bottom, let's erase this one. 1 times 4, we have 4 plus 3 times 6, we have 18. So we have 22. 22. Okay, so there you go. This is now the product. This is now the product of these matrices. Okay. So if you are going to multiply these matrices, this is not the answer. So don't forget the pattern. What you have to do when you are multiplying matrices, you just go from left to right, and then on the second matrix you have to go top to bottom. So 4 times 1 plus 2 times 0. After doing that, you move to the next column. 4 times 2 plus 2 times 1. 4 times 3 plus 2 times 1, negative 1. 4 times 4 plus 2 times 6. After reaching the last column of the second matrix, you go to the second row of the first matrix. And then repeating the same procedure. 1 times 1 plus 3 times 0. 1 times 2 times 3 times 1. 1 times 3 plus 3 times negative 1. 1 times 4 plus 3 times 6. So all the things that I am telling you right now, those are written on this matrix. And after that, we simplify this operation and we arrive having this answer. Okay, so let's have another example for multiplication of matrix. Let me erase this one. Okay, so let's say we have this given. We have 2, 3, 4, and 5, and then multiplied with 1, 3, 0, and 2. Well, let's say these are the given matrix. So the first thing that we have to do before we go on multiplication is we must see first if they are legal matrix in terms of multiplication of matrix. So does it conform to the rules of multiplication of matrix? How many columns do we have here? One column, one. So we have one column here. And then how many rows do we have here? So number of rows, we have one row. So let's check. Are they equal? Yes, because the number of columns is the same as the number of rows for the second matrix. So meaning we can legally multiply these two matrices. Okay, so let's perform multiplication now. Okay, so let's do this. So let's start with the first row of the first matrix, multiplying that to the first column of the second matrix. So the result of this would be like 2 times 1, and then after that 2 times 3, and then 2 times 0, and then 2 times 2. So we have already reached the last column, so let's move to the next row. So 3 times 1, 3 times 3, 3 times 0, and then 3 times 2. Okay, let's move downward. 4 times 1, 4 times 3, 4 times 0, and then 4 times 2. So I guess we can now follow the pattern. All numbers inside the parentheses are all the same. So let's just copy this. 5 times 1, 5 times 3, 5 times 0, and then 5 times 2. So there you go. Now let's simplify things. Okay, so let's create another matrix here. So 2 times 1, this becomes 2. 3 times 1, this becomes 3. And 4, and then 5. And then let's go to the second column. 2 times 3, this is 6. 3 times 3, this is 9. 4 times 3, this is 12. And then that is 15. Okay, third column, all of these are 0. And then the last column, that is 2 times 2, becomes 4. 3 times 2, that becomes 6. 4 times 2, that becomes 8. And 5 times 2, that becomes 10. So this is now the answer. Okay. So we have now a matrix that is 4 by 4 matrix. 4 rows and 4 columns. Okay. So this is now the answer. So that's all for this video, and then see you in the next lectures.